Hey guys, welcome to lesson 2 in unit 3. We're going to continue talking about ways we can translate English into algebraic expressions. So today's lesson is really going to talk about patterns. So let's take a look at the aim. I can create algebraic expressions and equations by translating English instructions and finding the mathematical pattern in the words. The new Common Core Algebra 1 curriculum challenges us to make sense out of mathematical patterns by utilizing the tools of algebra. Today we will explore patterns and then see if we can justify them by manipulating algebraic expressions. Be mindful of your manipulations, right? So that means be sure that what you're doing is making sense. So let's look at exercise number 1. Exercise number 1. Choose any number. So let's pick a number. Create the sum of 2 more than 3 times the number with 2 less than 2 times the number. What patterns is true of the result? Okay, so part A says, let's explore this pattern with numbers we know before working with algebraic expressions. So it's kind of like making a test number, right? Even using numbers, the English is a bit tricky to decipher. Let's do it together using a single number. So first, let's pick the number 3. So I'm choosing the number 3. And let's go to the English. The English says, create the sum. And let me use my colored pen here. Create the sum, so that means I'm adding something, right? I'm adding. That's what sum means. Let me scroll up. Going to add. Create the sum of 2 more than, so that's adding again, 2 more than 3 times the number. So I'm going to break there. So we've got this part, and then it breaks here. That's where we're putting our plus sign, right? With, let's pick a different color. 2 less than 2 times the number. That's the second part of the sum. So if I pick the number 3, I'm going to add 2 more than 3 times the number. So 2 more than 3 times the number. 2 more means add. So 2 more than 3 times the number. Well, the number we're picking is 3. So let me make that with black. So I'm picking the number 3. So 3 times 3, that's the first part of the sum. The second part says with, so I'm going to add that, plus 2 less than 2 times the number. Remember, 2 less than means subtract, and it goes at the end. So minus 2, 2 less than 2 times the number. So 2 times that 3 that we originally had. Okay? So 2 more, 2 plus, 3 times the number, with, there's the plus, 2 less than 2 times the number. Okay? So now I'm going to simplify that. Do a multiplication first. So 3 times 3 is 9. Plus 2 times 3 is 6 minus 2. Now remember, we do PEMDAS left to right. So this becomes 11 plus 6 minus 2. I'm going to continue up here. 11 plus 6 is 17. And I get 17 minus 2. 17 minus 2 equals 15. Okay? So when I have the number 3, right, my calculation gives me a result of 15. Okay? So that's one test. So that's part A. Okay, my calculations, I'm going to put right here, see above, because the calculations were done up there. Okay, now let's set up a table using various values to see if we can find a pattern. So I'm going to start with 3, but let's say we pick a different number. Let's say we pick the number 5. Let's do the exact same thing we did up here. So this exact same process right here, and now let's try it with the number 5. Okay, so I'm going to have 2 plus 3 times 5 now, plus 2 times 5 minus 2. So I'm just plugging in that 5 where I had the 3 originally to do the same calculation. Okay, so this is going to give me 2 plus 15 plus 10 minus 2. So I've got 17 plus 10 minus 2. That gives me 27 minus 2, which equals 25. So I get a result of 25. Let's pick a different number now. How about the number, I don't know, let's try 8. Okay, so now I've got 2 plus 3 times 8. Remember, I'm just changing in the 8. Plus 2 times 8 minus 2. I'm just using that the same English translation. I'm just trying different numbers to see if I can find a pattern. Okay, so I'm going to get 2 plus 3 times 8 is 24. plus 2 times 8 is 16 minus 2. That's going to give me, if I can move this up a little bit, that's going to give me 26 plus 16 minus 2. It's going to give me 42 minus 2, which is going to give me 40. Okay. And finally, let's try an easy number. Let's try the number 1. Okay, so 2 plus 3 times 1 plus 2 times 1 minus 2 equals, well, 2 plus 3 times 1 is 3, plus 2 times 1 is 2, and then minus 2. So left to right, I get 2 plus 3 is 5. Keep going, 5 plus 2 is 7. And 7 minus 2 is 5. So now that I've tried it with 4 different numbers, part C says, now let's prove the result you see in the table will always be true. Okay? And what that means is, what's this pattern that we're looking for? Right? How are we going from the number, let's get a different color here, this number 3, and how are we getting a 15? How are we going from the number 5 and getting a 25? How are we going from 8 and getting to 40? What's happening to 8 to 40, 5 to 25? Well, if you notice, each time we're multiplying by what? What times 3 gives you 15? 5. What times 5 gives you 25? 5. So there's this pattern here that the result is always 5 times the number. That's the pattern. No matter what number you pick, like here, 1. What's 1 times 5? 5. Okay? So now let's prove that it will always be true for any number we pick, right? And to do that, we have to use algebra. We use the letters. That's what this prove means, that we have to use algebra. So let the number now be called x. So I'm going to say that, x is going to equal the number that I have. Write an expression that translates the verbal description given for our calculation. So I'm going to take a look at my math here and notice, what did I keep the same in each one? In each one I kept the 2, right? I also kept the plus 3 times. But what was the only thing that changed? The 5, the 8, and the 1. So let's just make that x. Plus 2, I always kept the 2 the same, but then I changed this to be the x. Minus 2. And let's simplify this. So I get 2 plus 3x plus 2 times x, which is 2x minus 2. Now I can combine like terms, and I get 2 plus 3 gives me 5x. Plus 2 minus 2, these are done. And what is 2 minus 2? Plus 0, so I can just say that my pattern is 5x. And notice, this is the same thing as saying 5 times the number. So the algebra supports all of the trials we did in the chart, right? So really what we're doing is we're testing to make sure that our pattern is right. Okay? Let's take a look at exercise 2. Okay? If n represents a number, which of the following expressions represents the sum of 1 more than twice the number and 3 less than 5 times the number? Okay, so I see the word sum, which means that I'm going to add, and I need to look for that word and or with, and I see it right here. That word and represents where my plus sign goes for the sum. And then I notice it's split into 2 spots. One more than twice the number, and the other split is right here, with 3 less than 5 times the number. So let's start with the first part. 1 more than twice the number. Well, this 1 more than means we're adding. So 1 plus 1 more than twice the number. Twice means multiply by 2, and I have n. Now I'm making a sum, so I have to have my plus sign. So plus, let's do now the red part, 3 less than 5 times the number. Well, here's 5 times the number, and minus 3 for 3 less than. Okay, now that doesn't match any of my answer choices, right? And just to be clear, I'll write here that this means subtract right here, so you're not confused. And times means multiply. So now what do we have to do? Well, these don't match my answer choices, so I have to combine like terms. I see a 2n and a 5n. What's 2n plus 5n? 7n. These are done, so I cross them out, carry the 1 down, and the negative 3 down, and now I combine the 1 minus 3 to give me negative 2. And is that an answer choice? Yep, it's number 1. Okay, so this might be something that a Regents problem would look like, right? Okay, so this is combining like terms. And I do like the practice of canceling it out when you're done. So then I can see exactly what I'm left over. I'm left over with that 1, that -3 to bring down. Also keep in mind when a number is by itself, there's always that plus in front of it. That's why this became a +1, because I can always put the plus. Okay? Alright. This is a quick lesson, so let's take a look at exercise 3. It's the last part of the lesson. And this is basically what we did for the first exercise, only now we're going to think about multiplication. So now we're talking about some multiplication properties. So exercise 3, in this problem we'll explore the calculation of the difference between the product of a number and a number 5 larger than it, and the product of the number and a number 5 less than it. Will this reveal a pattern like the last one? Now this is a very complex sentence, right? We really need to practice breaking it up when we get to the algebraic expression part. So let's try it with a number first, a number we pick. And so in part A, it's going to say, let's explore the pattern with numbers we know before working with algebra. So let's let the number we choose be 10. So I'm going to pick the number 10. Okay, so here's my number 10. And what do we have to do with this number? Okay, it says, calculate the difference. So I'm going to, again, use different colors. The difference means what do we have to do? We're going to have to subtract the difference between the product of a number and number 5 larger than it, and, so there's that and where my minus sign is going to go. Okay, I'm going to put my minus sign. It's going to split those two things up. So here's my minus sign, and it splits them between these two sentences. And I'm going to use red for the first one. So let's focus on the first one. The product of a number and a number 5 larger than it. So product means multiply. So we're going to multiply. We're going to multiply the number. So n, is that what they want us to do? No, 10. So I want to start with 10. So here's 10 times a number 5 larger than it. So a number 5 larger than it, well, what's a number 5 larger than 10? 15. Right? That's a number 5 larger than it. We could also do this. We could say 10 times 10 plus 5. Because that means the same thing. It's 10 times a number 5 larger than 10. And, let's do the second part. I'll make that green. The product, so it's another product, of the number and number 5 less than it. So now we're saying, well, instead of 10 times 10 plus 5, we're going to say minus 10 times 10 minus 5. Okay? Okay, now we can simplify this, and I'm going to use black. This becomes 10 times 15 minus 10 times 5. So I get 150 minus 50 to give me 100. So my first number, when I used the number 10, I did the calculation, I got 100. Okay? And like the last one, let's try it with a few numbers. And I tell you what, I'm going to pick the numbers that I want you to try, and you can try it on your own. Try the number 20, try the number 3, and try the number 5, and see if you can not only get the calculations correct over here, the results, but see if you can find a pattern. This pattern part, see if you can find that. So pause the video and try to get these numbers on your own and find the pattern, okay? Okay, I've plugged in my numbers into my formula up here. Now I'm going to simplify. I have 20 times 25 minus 20 times 15. This is going to give me, again, I'm using a calculator, so I hope you are too. This is going to give me 500 minus 300. That's going to give me 200. Okay? This is the third one. This will give me 3 times 15 minus 3 times negative 2. So be careful there. 3 minus 5 is a negative 2. When I simplify, 3 times 15, oh, I'm sorry, I made a mistake. Let's go back. This is my mistake. Let me just rewrite that. Okay, because I know that you guys love to point out when I mess up, so I'm going to fix this so you guys can't steal my Jolly Ranchers anymore. Okay, so let's start again. 3 times 3 plus 5 minus 3 times 3 minus 5. Well, let's try this again. Okay, So I accidentally did multiplication when I did this, but this should be 3 times 8 minus 3 times negative 2. There we go. 3 times 8 is 24, minus 3 times negative 2 is a negative 6, but keep in mind we have two negatives, we get a positive, so 24 minus negative 6 gives me a positive 30. Okay. And finally 5. I'm going to have 5 times 5 plus 5 minus 5 times 5 minus 5. That's a lot of 5s, jeez. Then I've got 5 times 5 plus 5 is 10, minus 5 minus 5 is 0. Okay, so 5 times 10 is 50, minus, what's 5 times 0? 0, so that's just gone, and I'm just left with a 50. Okay, so now we have to think about what the pattern is. Well, how are we going from... Let me pick a different color for this. How are we going from the number 10 to the number 100? What do you do to the number 10 to get 100? What do you do to the number 20 to get 200? What do you do to 30 to get 30? And what do you do to 5 to get 50? If you said multiply by 10, you are correct. Right? The result is always 10 times the number. Now let's prove that result by using some algebra. So we want it to work for any number we choose, not just, 10, 23, and 5. So any number is going to be called x. Now let's write our expression, the same way we did the first exercise. So the expression, you can try this on your own first, like always. X, what am I doing to x? Well, I multiplied it times itself plus 5 more than the number, and then I subtracted it, x times x minus the number, right? That's everywhere I plugged in. I just decided to replace it with an x. So 3 here, 3 here, 3 here, 3 here, I just made it an x. Okay, now I'm going to simplify and distribute, right? X times x is x squared, and this is a multiplication symbol, by the way. X times 5 is 5x. Here, be careful with your sign, right? This is a negative, so it's negative x times x gives me a negative x squared, and this is a negative x times a negative 5, so I get a positive 5x. Okay, now I combine like terms. I see this negative x and this positive x. So this is like saying invisible 1 minus invisible 1. What's 1 minus 1? 0x squared. Then I've got 5x and 5x. 5 plus 5 is 10x. Well, 0x squared we don't write because it means 0. So this means that this is 10x. And does that make sense? Does this mean multiply by 10? Absolutely. So our pattern works. And we've proved it with our algebraic expression. Okay? Alright, feel free to move on to lesson 3.3 because your mastery in 3.2 and 3.3 are shared in this unit. So you don't need mastery for 3.2, but you do need it for 3.3. So good luck on your fluency, and if you need help, you always know where to go.